Hello students, once again welcome to this part of chapter Force and Laws of Motion of 9th class physics. Let us take a recap what we have studied in the previous slide, what we have studied in the previous part. We have ended our previous part to this balanced and unbalanced force. While discussing the balanced and unbalanced force, we have discussed this thing that when the forces acting on the body cancels out effects of each other such that the resultant force is zero. Now we have taken this example. Suppose from both the ends the force is applied. We have taken this example as the tug of war. While playing this tug of war, if suppose the force applied by both the sides is same, then the resultant force will be zero. That means for an effective happening of this balanced force, the resultant force is zero. Then this resultant force will only be possible only if from the two sides the equal force is applied. While discussing the unbalanced force, we have seen that if from one end the force applied is different from the force which is applied on the other end, then that particular force is considered as an unbalanced force. Here also we have seen that this example, suppose at this end the players have applied the force of pulling in terms of 400 Newton, and suppose in this direction these players are applying the force of pulling of 300 Newton. Definitely this 400 Newton is more than this 300 Newton. This type of force is called as an unbalanced force. So we have seen about balanced and unbalanced force. We have seen some examples where the balanced force we have seen. Suppose a block is there which is a heavy object from both the ends. These two mans are pushing. So force is applied by both the ends. If this magnitude of the force is same which is applied by both the ends, then this block will not move. Suppose an object is placed on the table, then the weight of this block is in downward direction. Obviously the reaction which is exerted by this table on this block will be a balanced force. So that's why this object is kept firmly on this table. Otherwise this object will not be on this table firmly. We have taken this example also. If suppose although in these examples, by applying the balanced force, there is no change, there is no displacement happens to the body. But there are some examples by which, even if the balanced force is applied, sometimes the shape of the object changes. So we have seen in this example that if suppose this balloon is inflated, but when it is compressed, when it is pressed from both the sides by our hands, then this balloon is deflated. So sometimes it is possible that even if the balanced force applied on the body, because of that balanced force, shape changes. Let us move ahead and let us see what is in this particular today's part over there. Let us see it. Now, let us move the second part in this particular chapter where we are going to study about laws of motion. And particularly I told you while discussing the introduction of this chapter, I told you that particularly we are going to study about Newton's laws of motion. So, before Newton's laws of motion, there is a concept where we have to study one phenomenon, that is nothing but the Galileo experiment. But the basics of the Galileo experiment, the foundation for the Galileo experiment arises from the experiment which is being built by Aristotle. You know, Aristotle is was one of the philosophers in ancient days, in ancient years, when he performed a lot of experiments while demonstration about the motion over here. So one of the important concepts which has been built by Aristotle in those days was he performed some experiments related with the force, and when the force is applied on the body, he was of the assumption that for a continuous motion of an object, a continuous force is necessary. So what Aristotle concluded at that time, that a constant force is needed to keep a body in motion with a constant velocity. But this idea was wrong. In those prevailing days, the experiments which Aristotle performed, he came to this conclusion that if suppose a force is applied on the body and because of that force the body is in motion, that means he concluded that whenever any body is to be kept in motion, a constant force is necessary, then and then only the object will be in motion. But actually this conclusion which was made by Aristotle was completely wrong. What was that conclusion? That conclusion was a constant force is needed to keep a body in motion with a constant velocity. That means if the force is not applied on the body will come to rest. It is an obvious thing that if suppose this is the conclusion which was made by Aristotle, this means that if the force is not applied on the body, that means the object is going to become at rest. So what is the outcome of this particular conclusion? The outcome is that if the force is not applied, that means if the force is ceased, the force is no more in existence on the body, then the body will come to rest. But this conclusion which was made by Aristotle was completely wrong. Later on, there was a scientist whose name was Galileo Galilei, performed some experiments on the basis of which he proved that the conclusion which was made by Aristotle was completely wrong. In fact, there is no need of any force to be the body is to be kept in motion. But how it is possible that if the force is not applied on the body, but even then the body is in motion? Let us try to understand what is the Galileo experiment first, and then we will come to know how exactly Galileo proved that Aristotle was wrong at that time. So this is the picture of Galileo Galilei. His time means his duration was in 16th century. What he claimed, what he has performed the experiment and what he has made the statement over there, for continuing the motion of the body in horizontal plane, no force is required. This was a very bold statement made at that time by Galileo Galilei, since it was a direct infringement of what the statement made by Aristotle at that time, because Aristotle made this statement that for a continuous motion of the body, a continuous force is necessary. But Galileo's statement is completely opposite to that particular conclusion which was made by Aristotle. So what according to Galileo said that for continuing the motion of the body, suppose the body is in motion, for continuing the motion of the body in a horizontal plane, no force is required. Even in today's days also, this statement which was made by Galileo feels surprising to us. Why? Because if the force is not applied on the body, how come it's possible that a body will be in motion? But there are certain circumstances, there are some factors which affects on the motion of the body, like friction. Even though the force is ceased, according to Galileo's statement, the motion of the body should continue. But we normally used to see that if suppose a bicycle is there, if we stop pedaling the bicycle, then after some time the bicycle will stop. But this is exactly the example which is not according to the Galileo. What was Galileo's statement? Galileo's statement is that for continuing the motion of the body, force is not required. But we are applying the force in terms of pedaling of the bicycle. The moment we stop the pedaling, that means we are stopping the application of force. But the moment we stop the application of the force, the cycle should have come rest. But the cycle is coming rest. In fact, according to the Galileo statement, the cycle should continue its motion. So what are those factors which tells that object, tells the cycle to come to at rest? To understand this, let us try to understand what the experiment which was performed by the Galileo. This experiment was one of the milestone experiment in the development of the mechanics, in the development of the study of the motion of the object. Let us try to understand what exactly this particular experiment which was performed by the Galileo. Yes, this is the demonstration of experimental setup of Galileo's experiment. Let us try to understand what exactly the experimental setup which was performed by the Galileo. Galileo took two planes, two inclined planes. So let us imagine this is one of the inclined plane and this is another inclined plane. Now what he did, suppose he took a marble, a metallic ball, and he left this metallic ball at this position. Let us imagine the height of this metallic ball from this horizontal surface, that is from the bottom, is nothing but h. So we can consider that the object, which is nothing but this ball, which is a metallic ball, is released from this height h. So obviously now the slope of this particular surface is towards this end, so obviously the ball will roll down and it will come to this position. But this ball will not stop here. Though this plane is inclined from this end, even though because of this rolling action the ball moves ahead and it will go at this particular height. So what Galileo found here, that approximately the height from which the ball was released, the ball when reaches on the second plane at this inclination